Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on straight lines. This is the first lesson in a new unit on coordinate geometry. In this unit, we will study specific principles related to lines and circles. We will also learn about the properties of conic sections. Are you ready, students? Let us begin. Previously, you learned how to find the equation of a line and how to tell whether two lines are parallel or perpendicular by examining their slopes. Let us start today's lesson with a review activity. Students, here are 2 points, P 1, 4 and Q 3, -2. Find the equation of a line passing through P and Q. Identify its slope and y-intercept.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back. To find the equation of a line passing through 2 points, we use this formula. Y minus y1 equals y2 minus y1 over x2 minus x1 multiplied by x minus x1. When we substitute the xy coordinates from points P and Q, we find the equation of the line to be y equals negative 3x plus 7. The equation of a line is y equals mx plus b, where m is the slope and b is the y-intercept. Therefore, the slope of this line is negative 3 and the y-intercept is 7. Any 2 points will give us a straight line. To find its slope, we use the ratio of y2 minus y1 over x2 minus x1. If x2 equals x1, then the line is vertical. It has no slope. If 2 lines have the same slope, they are parallel. If the product of the slope of 2 lines is negative 1, the lines are perpendicular. If 2 lines are neither parallel nor perpendicular, then they must intersect at some point that does not form a right angle. To determine the angle between the 2 lines, we must find the angles of inclination. In this graph, the angle alpha is measured from the x-axis to the line in the counterclockwise direction. Alpha is the angle of inclination. The tan of alpha is found by taking y over x minus x0. This is the same formula for finding the slope of the line. Therefore, the slope of the line is equal to the tan of alpha. What happens when we add a second line? In this graph, the angle between 2 intersecting lines, L1 and L2, is angle beta. Beta is measured counterclockwise from L1 to L2. There is a third angle indicated called gamma. Gamma is the angle of inclination for L2, just as alpha is the angle of inclination for L1. Beta equals gamma minus alpha. This means that the tan of beta equals the tan of gamma minus alpha. If we expand the brackets, we get the equation seen here. Since we know that the tangent of an angle is equal to the slope of the line, our equation to find angle beta becomes m2 minus m1 over 1 plus the product of m1 and m2. Students, please use this equation to find the tangent of the angle between these two lines.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, everyone. We are using this equation. By substitution, we get -1 minus -3 over 1 plus the product of -1 and -3. This gives us 2 over 4, which is 1 over 2. So, the tan of beta equals 1 over 2. Suppose that we are given a line L and a point P at x, y. If P does not lie on L, then we define the distance from P to L as their perpendicular distance. If P is at the origin of the coordinate system, a perpendicular line drawn to L will form a right-angled triangle. Let L be the line AX plus BY plus C equals 0. To find the distance from the origin to any line of this form, we take the absolute value of C and divide it by the square root of A squared plus B squared. For example, a line is 2y equals 5x minus 7. First, change this to the form 5x minus 2y minus 7 equals 0. To find the distance from the origin, we take the absolute value of negative 7 over the square root of 5 squared plus negative 2 squared. The distance from the origin is 7 over the square root of 29 units. What if P does not lie on the origin? Suppose that P has the coordinates h, k. We can draw a new x prime, y prime coordinate system such that the origin of the new system is at hk. X prime equals x minus h and y prime equals y minus k. The equation of the line in the new system becomes a prime x prime plus b prime y prime plus c prime equals 0. By substitution, we get this result. If we expand the brackets, our result is a prime x plus b prime y plus c prime minus a prime h minus b prime k equals 0. When we translate this into the original coordinate system, we find that A equals A prime, B equals B prime, and C equals C prime minus A prime H minus B prime K. So, C prime equals AH plus BK plus C. The distance from a point at HK to line L is given by the absolute value of AH plus BK plus C over the square root of A squared plus B squared. For example, to find the distance between P at negative 3, 2 and the line 5x plus 4y minus 3 equals 0, we substitute these values into the formula. The distance between P and L is 10 over the square root of 41 units. Today we reviewed the equation of a line, and we learned how to find the measure of an angle between two lines on the coordinate plane. We also learned how to find the distance between a point and a line. Until next time, thank you, teacher. Thank you, students.